For number 6, we are comparing 3 different means, and our situation here is the number of corn plants in rows for different types of farming techniques, and our null hypothesis is always that the means are all going to be equal. Our alternative then is that at least one of the means is different from the others. And to do this hypothesis test, we're going to use a procedure called ANOVA, which stands for Analysis of Variation. And there's requirements that must be met before we can use ANOVA. And get into the ebook, MyStatLab, the e-text, and look at comparing 3 or more means here. And in Objective 1, you will see the 4 requirements necessary in order to perform a one-way ANOVA test. So select those 4 requirements here, and then in the next part we have a one-way ANOVA table, and I'll show later in this video how to create a table like this in StatCrunch. But for now, this is where you see your test statistic, and then this is the p-value for that test statistic. So to decide whether to reject the null hypothesis or not, since the p-value is less than alpha, we will reject the null hypothesis, which that means there's sufficient evidence to support the alternative, which in this case, that the means are not all equal. At least one of the means is different from the others. If one of the means is different from the others, the box plot for that data should be shifted further away from the other data. And we see that here with this box plot being a lot further to the right than the other two. So yes, the box plot supports that at least one of the means is significantly different. For this part here, to verify that the residuals are normally distributed, we're going to look at our correlation coefficient here, R, and we need to use this table up here. So first look at our data. With our corn plants, we had 1, 2, 3, 4, 5, 6 pieces of data from each of our different populations. So our sample size here is 6. So for a sample size of 6, our critical value is 0.888. As long as the correlation coefficient is greater than 0.888, then we have evidence that the plot is linear enough when R is greater than that critical value. In number 7, we're using one-way ANOVA to test 3 different means. In this example, we have a stock analyst and checking the mean rate of return for 3 different types of stock. Our null hypothesis is always that the means are going to be equal. Our alternative is that at least one of the means is different from the others. For the next part, we're checking to see if the requirements are met to use a one-way ANOVA procedure. Going to section 13.1 of the e-text, you see the 4 requirements that need to be met listed. And so make sure you select the answer that says yes and then has the correct 4 requirements listed out. So next we're actually going to use StatCrunch and get a test statistic and determine whether we should reject the null hypothesis or not. So we're going to want to open this data in StatCrunch. In StatCrunch, you want to go to Stat, ANOVA, and then One Way, and then select our 3 different, holding down Control as I click on these to make sure all 3 of them show up here, and then I'm going to hit Compute. And so we get our one-way ANOVA table. Here is our test statistic, and here's the p-value for that test statistic. And so looking at that p-value, we compare it to our level of significance alpha. Since our p-value is greater than alpha, there is not enough evidence to reject the null hypothesis. Remember then, the null said that all the means were equal to each other, so we cannot conclude that the mean rate of returns are different since we're not rejecting the null. And we're going to jump back into StatCrunch to look at the 3 box plots and then find the one that matches up to the correct one here in our problem. In StatCrunch, go to Graph and then Box Plot. And we can do all 3 at once here. If we hold down Control, they'll all show up. and go ahead and hit compute. Now notice these are vertical up and down, while over here in the problem, they are drawn horizontally. So what you get in StatCrunch, you're going to have to mentally rotate it sideways to get it to line up with the answers and find the correct one. And just look at the scale here and look at how far the whiskers are going and where that middle line comes on the scale. And you'll be able to find the correct one in your answer. Make sure you're all also paying attention to the labels. Which one is financial, energy, utilities? So over here, financials on the bottom, so financial, energy, and then utilities. For number 8, doing a one-way ANOVA test. This scenario involves crash testing cars and 3 different types of cars, family cars, passenger vans, and mid-size SUVs. We're going to look at the mean head injury resulting from the type of crash test described here. Our hypothesis test, null hypothesis, is always that the means are going to be equal to each other. And our alternative hypothesis is that at least one of the means is different from the others. Part B, it says that our populations are normal. And then it asks if all of the requirements for a one-way ANOVA test are satisfied. So going to the e-text 13.1, the 4 requirements are listed. In the first requirement, our K would be 3 since we're looking at 3 types of cars. And we have 3 simple random samples from 3 different populations. The 3 samples are independent of each other, just with the way the crash testing was described in the problem. It's an independent procedure. The cars crashed in one group are not related in any way to the cars crashed in the other groups. The start of question B told us that the populations were normally distributed, so we have that. And then for requirement 4, the populations must have the same variance. To test that, go to the next page here, and it shows you how to verify that requirement. You look at the largest sample standard deviation from your 3 different samples and make sure it is not more than twice as large as the smallest sample standard deviation. And we can do that in StatCrunch. Open up the data in StatCrunch, go to Stat, ANOVA one way, and then holding Control, click on all of our 3 different samples so they all show up. Hit Compute, and this top table here shows us the mean and standard deviation for each of our samples. And we want to compare these standard deviations and make sure that the largest one here is not more than twice as big as the smallest one. And so 130 doubled would be 260, which is bigger than our largest one. So that 4th requirement is met along with the other 3. So now in StatCrunch, we can go back to where we just were and find the test statistic and the p-value. Down here in the one-way ANOVA table, the test statistic is listed along with the p-value. And since this p-value is larger than our level of significance here, alpha, we will not reject the null hypothesis. And so we cannot conclude that any of the means are different from each other, since our null hypothesis states that they're all equal, and we're not rejecting that. Back in StatCrunch, we can draw box plots by going to Graph, Box Plot. If you hold Control as you click, you get all 3 of them at once over there. And pay attention to which box plot represents which type of car by reading the labels down here. And then look at the whiskers on either end of the box plot, the line in the middle, and see where all of those things line up here on your scale to the left. And so using those values on the scale, do a little mental rotation, and you can line it up with the scale here in the answer to where the whiskers and the middle lines line up, and you should be able to match the correct box plot. For number 9, we're doing a one-way ANOVA test with the mean strengths for different type of concrete mixes. Our null hypothesis is always that the means will be equal to each other, and the alternative is that at least one of the means is different from the others. B says explain why we cannot use one-way ANOVA to test these hypotheses. In the e-text 13.1, it discusses the 4 requirements that we need for the one-way ANOVA test. And we're going to look at this 4th one here. The populations must have the same variance. To test that, we look over here at the next page. The largest sample standard deviation cannot be more than twice the smallest sample standard deviation. So clicking here, we can open our data in StatCrunch. If we go to Stat ANOVA one way, hold Control as we click on our 3 samples so they all show up, hit Compute, we see the standard deviation showing up for our samples. Now if we take the smallest one and double it, we're getting around 218. And the largest sample standard deviation is bigger than 218. So that does not fit the requirement we needed. And so that's the reason that we cannot use the one-way ANOVA test. Number 10 is asking 2 questions. The first are what are the requirements to perform a one-way ANOVA? And is the test robust? In the e-text 13.1, the 4 requirements are listed. So make sure you select the correct 4 that match up. And then clicking to the next page, you'll see at the top it says that the one-way ANOVA is robust. If there's a small departure from normality, it will not significantly affect the results of the procedure. And so that's the answer you want to select here.